Hello, protocols, packets, and programs. I am a firm believer that security awareness programs can replace expensive and boring slides with limericks. For example, a programmer learned solidity, then had a spark of lucidity. They thought code is law, but missed a small flaw, and now have zero liquidity. Which means this week we chat with Shashank about OWASP's smart contract top 10, attacks that outsmart smart contracts, and how to be smarter about security. Think smart and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. This is episode 322, recorded March 17th, 2025. I'm your host, Mike Shima. And here with me is Shashank, who is the CEO and co-founder of CredShields. With 12 plus years of cybersecurity experience, he has discovered critical vulns for Apple, Google, Microsoft, and Facebook, earning multiple CVE credits and recognition in their Security Hall of Fame. Before founding CredShields, Shashank worked as a security analyst at HackerOne and a security engineer at Avalanche, where he identified major blockchain vulns, which I think are always tend to be pretty major. Hello, Shashank. Thank you for joining us.
Hi, Mike. Nice to meet you.
So this episode for me is kind of funny because listeners may know that I tend to make fun of top 10 lists and also tend to make fun of cryptocurrency because of the world of scams. And here we are talking about both. But we're talking about both because let's start with the top 10. For me, this is actually a top 10 that's not redundant, not repetitive, that's actually very well written and domain specific. So before we get into the actual list itself, tell us a little bit about the inspiration. What inspired you to start listing out a bunch of these types of vulnerabilities?
Yeah, sure, Mike. So I'm glad, it's like I'm making a positive change where, where the world of cryptocurrencies is overshadowed by their scams and, the price manipulations and everything. Here we are talking about the core technology behind
Yes.
it, which is more of a beauty. It's like when actually seeing with the eyes of, the techies. What inspired me to write this was, initially when I founded this company, the story behind that was, I saw a pattern, it's like, which I spent a fair share, like almost a decade in, it's like Web2 security. And we saw, it's like the transition of, it's like the bug bounty programs and then, it's like private pen test. And then a lot of companies started writing automation tools. And I believe that, it's like if blockchain is the future, while we say, Web 3.0, the future of, web technologies. I believe that, it's like we had bug bounty programs here as well. We had private pen tests here as well. But the future would be, it's like writing automations as well to scale security. So while we were doing all these research, from past 3 years, we have been, it's like decoding all the hacks which has happened. We decoded it, wrote articles about it. And those were our knowledge source for our own tool. So while we were doing all these researches, we came across this, it's like a common problem that, we don't have any measurements. Like, when I was doing pen test, as a pen tester in Web2, we used to follow ASVS checklist or, it's like NIST standards. We used to refer to, it's like CWEs, etc. But there was no standard here. It's like we just came up with names and we had to just write anything what felt like, and there were some common names which were, it's like widely accepted somewhere, it's like rewritten, reformed, etc. So we realized, like, why not, use our own research of like past 3 years to draft the entire, it's like SCS, like smart contract security verification standards, and the enumerations as well, weakness enumerations. So for that, we realized we just needed two things. One was, it's like the data source. Second was, it's like lots of research, and we had both of them, and that's where we drafted the OWASP top 10 as well for smart contract security. So all we did was, all the past years, like 2024's, all the hacks which we had, we just classified it, and then found and labeled, as per the occurrence, which were more, and then we went ahead and drafted that, and I'm glad it got into it.
And it's interesting that you mentioned like CWE and the other types of like just the NIST references, because if we looked at the smart contract world, there are some commonalities: integer overflow, integer underflow. That's, Microsoft was talking about an attempt at a safe int implementation 20 years ago. There is insecure randomness. Every place in the world of cryptography, there's always a big concern about, is this cryptographically secure randomness? There are things like, in the older version of your list, even timestamp dependencies or time, references to time. And the reason I'm rattling these off is that CWEs, we can't exactly ignore them, of course, but they start to get very interesting and domain specific as you start to seize like, well, what does it mean for a reentrancy attack now? Or what does, what about those integer overflows? How do they impact smart contracts? So let's start to break those down a little bit in just, I mentioned reentrancy, integer misbehavior. What's one that stands out for you in particular on this top 10 list that we should really highlight first?
I mean, that's an interesting one because it resonates a lot with the Web2 world as well. So if you see the top 10 list, the highest one, like top one, is still the access control vulnerability, which has plagued the Web2 world as well. And how it works is, it's like so even in smart contracts there are RBACs in place. It's like there are admin features, and then there are features which is meant for the users. And once, and when, it's like there are, it's like some, it's like missed protection mechanism in the access control, the external users take over the admin privileges, and things are much more fatal here in, it's like in smart contract world, because it's not just the loss of data, it's loss of money. You lose ethers, you lose Bitcoin. And it still stands out, on the top one, because access control vulnerability is still the top in top 10.
And what's interesting to me is that if we talk about solidity, for example, access controls do have pretty clear, I think it's fair to say, decorations in the language. You can say things like, what is it, external only owner, or you can have labels that feel like this is where the access control should be. And the reason I'm highlighting that is, shouldn't those be easy to scan for? Shouldn't those, I realize as I say this, obviously the answer is going to be no, but maybe let's ask it, why do people still make those mistakes? Is this, somewhat of a language problem? Is this a developer confusion? Help us understand a little bit more of these access control failures.
So, I mean, it's like the access control failures is pretty much same, it's like it's a developer issue, because, it's like, and it's very, very common, like what we have, it's like when we have asked questions around it, like how this was missed. It was, the answers were pretty much the same what we see in the Web2 world. Maybe, it's like the developer was inexperienced, or the developer was under pressure to, it's like make, it's like meet the deadlines, or it was, it's like the code became at certain point, the code became so complicated, or, it's like there were multiple people working on that, and, and it was missed. So the problem still remains the same. And that's where, it's like the scanning feature comes into place. And the best part about, it's like scanning for access control vulnerabilities is it's not as easy as it sounds. That, it's like, okay, someone, for example, let's talk about, it's like someone forget to add a modifier, or added an incorrect modifier. And when you go for an automated approach, how do you approach that? So ideally, it's like, it's like one common way would be, it's like if a modifier was created, and within a contract where it's like most of the admin functions are being called, if some function is missing something, we can potentially flag it, it's like using automations that okay, and something was missed here. But it comes with a bigger problem of, it's like false positives as well, that, you might end up flagging a lot of functions which actually never needed an, it's like a modifier. And that's where, it's like the beauty of AI comes into picture. Because previously, even with, Web 2 vulnerabilities, automation of access control vulnerabilities were a problem. You could automate cross-site sifting vulnerabilities, SQL injection vulnerabilities, and we went with a very, it's like fair accuracy for that. But for access control, IDORs, it's like even the Web 2 tools are still lacking, and that's where, we started working on AI, where, it's like the best part of smart contract codes are that they are always, open source, and hence we have the context of the entire source code. Now, if you provide, feed in the functions to an AI or to an LLM model, it is fairly possible to, it's like detect if that function required admin privileges or not. And that's how it's like you manage to reduce false positive by a huge margin. Like, I mean, I did a talk on that where I said, it's like, showing the numbers, and we did almost 80% reduction in false positives.
Yeah, and I'll make sure to add a link to that. This was an AppSec Days talk on using LLMs for analysis. So I want to lean into this a bit more because we were talking about access control vulnerabilities. As you pointed out, perhaps I do live in the Web 2.0 world, but that is familiar to Web 1.0 as well, right? What's interesting about the smart contract top 10 is then you start to get into some things that, on the one hand, are very easy quantifiers of just how bad this is. We don't need CVSS scores. We can just point out and say like, oh, this was a few million, this is a few dozen million, here's a billion lost in our contract. And here I'm pointing to things that are very domain specific of the price oracle manipulation and flash loan attacks. These are very much just what contracts are supposed to do, or what developers intended smart contracts to handle money. Tell us a little bit about these two entries.
Sure. I mean, let's talk about, price manipulation attacks, like Oracle price manipulation attacks. There are many complex vulnerabilities here. I'll go with the first one, which is the very simple one. Okay. So to understand price oracles, first we need to understand what oracles are. So in the blockchain world, everything is on chain. Okay. And like in the Web 2 world, we have, it's like price feeds for, like, if you are, for example, if you're gambling on, it's like maybe, it's like a binary options website where, you bet on the ratio of Ethereum, USD and Euro. So these type of application exist, and they have a price feed. It's like all the stock options and everything gets a price feed at, okay, the current price is this, right? For the decentralized world, it's like the price feed also got decentralized. So for example, I have a decentralized exchange where I allow you to trade between Ethereum to some, maybe Shashank token. And for the current price feed, what is the value of Shashank? The decentralized exchange would collect these feeds of price. For example, if Shashank is $1, it is being fetched from multiple, like resources, and those providers are called oracles. Some famous ones are like Chainlink and Telor. And recently, it's like not recently. So one time, I'll discuss two cases which are both interesting. So one thing was not very much, it's like about external oracles. It was more within the system. So in the crypto world, we have stable coins, which is supposed to hold the value of $1. And we have USDC, we have USDT. So similarly, if you have heard about the Luna, which was a coin which went down the drain, and it's like billions of dollars were lost. So Luna also had a stable coin called USD. And what happened was, when Luna was crashing, it's because it was based on Luna as well. The value of the stable currency was depegging. It was no more $1, and it was falling to it's like 90 cents and 80 cents and 50 cents, 40 cents.
Bad things.
During that time, a lot of decentralized exchange got hacked, was because they hard coded the value of USD to $1. Now, this is a classic, it's like a misassumption that they assume that okay, USD will always be $1. So now what the hackers started doing was, since the value was $1, they were buying from exchanges for for some amount, and they were using USD as a collateral, and then borrow some other currencies like maybe Ethereum or something like that, and they were walking out of profit, and that drained the entire the entire DeFi.
Yeah,
Second,
and what's cool about that is that that price oracle is not representative of what the market really is seeing in the supply and demand for that. Whereas flash loan, you're actually manipulating that a bit too. And I don't want to jump ahead, but I wanted to help our listeners understand those nuances there. So back to you, Shashank.
So and this was a classic mistake. And second one is actually manipulation of external oracles. So there was this. Let me check the name. This was a Bong DAO. Yeah, the Bong DAO protocol hack. So the Bong DAO, they had they were fetching values of the token through Telor, and what the hacker did was he or she became the price feeder at Telor. So the rule was you deposit 10 Telor's native token, and how Telor works is that okay, if you're providing the right feed, you get rewards for that. And if you provide the wrong feed because you have deposited a collateral on Telor, you get slashed, you get punished for that. But then here the upside was more, so what he did was he became, for a certain token, the attacker became the price feed provider, and he or she set the price to a very high value in multiple millions. And now then, because the price feed is being absorbed by the DeFi, the DeFi app, the value it shows is very high, and then the prices is high, although he or she is getting slashed there, but here it's minting millions. And that's the Bonk DAO hack was it costed 120 million.
Yeah, and that's the thing is what's amazing to me is how much of let's call it the Web3 world is kind of a self-funding bug bounty. That if you find this flaw, then you kind of get to keep the money. And a lot of times the exchanges or the DeFi places are like, we'll let you keep 10%, 20% if you just give us the money back, please. Right. I wanted to jump on, maybe we can talk about flash loans in a second. It can come up in some of these other vulnerabilities.
Sure.
But as we're talking about this, like you're talking about abusing information or mismatches of where the more correct information is or who has the latest correct information, as you were describing with that price oracle manipulation, that's something that I don't think, just the language itself can start to fix. But as I did mention, like integer misbehaving, integer overflows, things like access control vulnerabilities, maybe a little bit, those feel, or reentrancy, we can also introduce that now because I think that relates to flash loans as well. Those feel like language problems though. So let's pull in solidity a little bit. And have you seen over the lifetime of your research into this area, your lifetime of tracking this top 10 list, how has the language improved, or where do you wish the language was improving to keep up with some of these flaws that keep happening?
So yes, language has pretty much improved, and it's like 3 years back when we started. We were creating a lot of detection patterns, especially for integer overflows and underflows, because Solidity by default had overflow and underflow bugs. So for example, if you are creating a uint 8, so that creates a possibilities of maximum number of 2 to the power of 8, which is 64. So as you go to 65, you get overflown, and this was causing a lot of hacks, and then suddenly in Solidity version 0.8.0, they came up with a fix at the compiler level. So right now, if you actually if you just make a uint 8 and try to overflow it, it won't. Or even if you try to subtract and make it underflow, it won't work. So yes, Solidity has improved on its own, and one of the classic example is they fixed buffer overflows at compiler level itself.
The reason I wanted to highlight that is I like the idea that the compiler, the language, can introduce more security just so developers can use it safely by default. But reentrancy is one of those things I want to add too that can be, even for, if I've mentioned something like Rust or Go that has maybe easier primitives to use or primitives that are harder to misuse in terms of reentrancy. JavaScript world, which I mentioned because JavaScript, ECMAScript, it's very much like Solidity. Those are still confusing. So tell us a little bit about this reentrancy aspect and just trying to keep two threads at once. And as you can tell, I'm already doing my own reentrancy attack by jumping around in topics in this very question.
Sure. So I'm not sure if reentrancy could be fixed at compiler level. As per my knowledge, I'm not sure, because reentrancy here in the concept of smart contracts, how it works is like it depends on the logic which you used for your state changing functions. But then people have come around with for example, we have pip for Python, where you can just pip install few things and then call the function and make things secure, or do a lot of things. So Open Zeppelin, which is which is a Web3 company, they write a lot of such modules called Open Zeppelin modules, and there is one thing called reentrancy guard which they have written. So for example, if you are not sure, you wrote a very complicated function and you're not sure, if it is vulnerable to reentrancy attacks or something like that, just import, reentrancy guard and add the modifier, non-reentrant it's called. And it will protect the function from all sorts of reentrancy attacks. So these things, even if it's not fixed at compiler level, people have come up with, with workarounds and, protection mechanisms to avoid, reentrancy attacks.
So, and part of that then is the idea that the state of what you have in your contract might be manipulated by, as you were saying, external sources, right? Or that's that Oracle manipulation. Maybe it's reacting differently, or even flash loan attacks. Let me, I mentioned that earlier. Tell us a little bit about how that flash loan attack works. That's something that's very unique to the smart contract world.
Yeah. So if you see, it's like the idea behind flash loan attacks, it's not at all a technical vulnerability. It's more of an economical vulnerability, where the hackers actually find a way to make to do certain trades and always end up with a profit. And that's how most of the flash loan attacks works. A classic flash loan attack, how it works is mostly it happens for tokens which has lower liquidity or lesser protection mechanism, etc. So what happens is, like, for example, I see that, okay, there is a particular token which has lower liquidity. Problem with lower liquidity of any token or any any token is that when you push in a lot of money into that, you can inflate the prices up and down. Okay, so classic steps of a flash loan attack is there are protocols like Aave and Compound where you can where you can take a loan for a short period of time. Okay, so attackers actually use these nice features to borrow a lot of money for a short time because they know that they are going to make profit. So for example, I borrow maybe a huge amount of ether and then use that ether to inflate the price of a particular token. So for example, the current price of a token was that 1 ether equals to 100 token. Now, because of lower liquidity, what I'm doing is, I'm buying a lot of, such tokens, which is increasing the price of the token. Now, 50 of such tokens is equal to 1 ether. So, my ether value, what I took as loan, has increased. Now, if the DeFi app is not checking those things, what I can do is, using the current price of the inflated value of the token, I am taking another collateral, which at an increased price. So now I got 2 ethers for the same price, and now I repay back the loan on the other DeFi where I took the loan, and every time I'm making 1 ether as a profit. And I keep on repeating that unless the current DeFi product is drained out. So it's more of an, a logical and, economical vulnerability specifically to, like smart contracts and DeFi applications.
Yeah, and I love that because there's a common phrase, just business logic is a really easy, it's a bit of a throwaway phrase in the world of just general web application security that's intended to capture things like what are the workflows, what's the feature set of the application, and figuring out then was that implemented in a secure way. And the reason I'm talking at a high level is that it's unfortunately a very generic category. But what you were just describing is very clear examples, how to understand that this wasn't necessarily something you can check for in the, like you could, that a SAST tool that you can just grep for. Am I vulnerable? Did I make a mistake in business logic? You've got someone who's got that economic intelligence to understand if I artificially inflate this supply or the demand for this, price goes up, I quickly sell it, price crashes. But in that interim, I made that money. And the reason I'm setting that up is that I started talking about scanning, being able to check for these. You pointed out too, all these smart contracts are in fact open, visible. How do people keep missing this? I'm going to ask that hard, sort of frustrating question. Why do people keep missing these types of things? What are the nuances here that we should be educating people about better?
See, it's like if you talk about common infosec terms, there is a term in infosec. I forgot the exact term, which basically says that if you reduce the availability of it's like anything, you reduce the attack surface as well. And that's what happens in the Web2 world. That it's like maybe it's like even somewhere in Google's it's like entire system, there might be a race condition still hidden, no bug bounty hunters have found yet. But here, it's like the source code is public, so it's in the eyes of everyone. So it brings both the pros and cons. It's like as more and more people get educated, it's like Solidity is still a very new language. You won't find a lot of Solidity developers around in the world, or you go to a college and look for a Solidity developer for hire. You won't get that. You might get a Python developer, Java developer, anything. So I think right now it's in a very nascent stage. A lot of people are learning. So the exploiters have an edge because they were early adopters, and it's like they have malicious intent and they are misusing their knowledge. I think that happened with at one point with even it's like web technologies as well, Web2 as well, when the SQLi was open in every second page, and people were it's like hacking websites like anything. But then it's like things are better now because the frameworks have updated. It's like people are more aware. And again, it's like podcasts like this. I'm pretty sure 10 people will learn about. Oh, okay, this is something we should not do, or this is something while writing smart contracts I need to take care of. So that is my answer. It's like as the awareness grows, we'll have a much secure ecosystem.
Yes, and I could probably name off all 10 of our listeners too by name, but I appreciate that. One of the things I've also got a link to in our show notes is to the Web3 Hack Hub. And this is part of the Solidity scan that you worked on. And looking at the attack trends that you have listed, are the top one is access control. We touched on that. Second one is logic errors. We just talked about that a little bit. I think there's still more we could go there. But the third one is rug pull. And of course, I did mention scams, and that's always going to be on the top of my mind anytime we're talking about this domain. But what's interesting to me is you just said, and I also pointed out, we're talking about it's all open source. Everyone can read these contracts. How much of this, how much could we predict, this is going to be a rug pull because look at this contract, versus we just don't know what the malicious actors are behind the scenes? How do you have that as number 3 from a detection or a scanning perspective?
Sure. So initially, this resonates with our it's like company's story as well. So initially, we it's like we wrote for vulnerability detectors, and we were catering the needs of it's like of developers, and the companies were writing smart contracts. But then it's like we would many times we would see in our chat box that I scanned this contract. It looks safe, but what? I got scammed. So our problem was, even if there is no like security vulnerability, the admin can have a withdraw function that withdraws all the funds. And how do you categorize that? That was the questions we were asking ourselves, like where do you categorize it's like an admin having a withdraw function to withdraw all the funds, and he has a deposit function to it's like take money, do all of the stuff, but then there is one withdraw function. It is neither a vulnerability, but then it is something which categorizes as a risk. So we decided, it's like let's note down some common, it's like ways where the admin could, so rug pull is basically, it's like the owner uh, goes rogue, and then it's like they pull out all the funds for themselves and then runs away with the money, uh, instead of keeping the platform alive for its users. So what the next thing what we realized was a lot of these users were there to use the platform. Although the code is public, but the problem is they don't understand Solidity programming language, and that's very common for even normal users. Like we are technical people, so we'll go to a website and we'll figure out, oh, okay, maybe the website is down because of these. But then there will be people who are frustrated, oh, this website never works. So the same thing happens at smart contract level as well. It's like there are technical users who will be like, oh, let's see the code. Okay, this looks suspicious. I'm not gonna. Then there are lots of people who don't. So what we did was we started, it's like processing the code, and we also started doing, it's like simulations. So the best part about smart contract is that everything is public. So what we started doing was, we would fork the current contract state at the particular block level, and then create a sandbox environment of that. And then we would start, it's like making random trades on that. For example, the check was the threats would be, it's like if I deposit the token and then if I'm not able to sell it, that's a threat. That's not a threat. It's basically a risk. It's a risk.
Risk, yeah.
It's a risk. If I'm allowed to sell, but my taxes, the fee which is being asked by the admin is like 50%. That's a risk. For example, it's like if there is a token and there is one particular address which has like 50% of the supply, that's a risk. Again, it's not a vulnerability, but it's a risk. So we created like 35, somewhere around 35 patterns, which is again subjective, that it's like maybe that is a feature, but then the user should be aware that, okay, what, these are the things which your admin has, and be careful what you wish for. So that's how it works.
Yeah, it's almost here's the rug pull oracle in a way that you're creating. Here's how to like give some transparency for that user to understand if they're going to be, if their money's going to be safe or not.
Basically, it's saying that you don't understand Solidity code. So what we have done is like we have converted it into plain English language for you with red and green flags stating that, okay, this is good, this is bad, this is fine, this is okay, and that's how you make a judgment what you want to do.
Well, let's talk about that LLM presentation you did, because what you just described was turning your own human intelligence into those green lights, red lights for other humans to understand in plain language, which is extremely helpful, especially in a more technical domain like this. People could also potentially turn to an LLM and just say, hey, LLM, is this contract safe or not? And that's at a high level. That's perhaps an unfair summary of what you did. Tell us a little bit more about how LLMs were helpful for you, or what were the challenges that you ran into for an LLM to actually correctly understand on the same level of human intelligence that you've demonstrated so far.
Sure. So this was actually a very nice story. So, it's like when ChatGPT came in, it's like even our investors were, it's like questioning that, are you sure you guys going to survive? Because Twitter is full of, it's like, analysis that, the AIs can detect all these things, etc., etc. So what we decided was like, let's give AI a shot. And we did few interesting experiments. So first, it's like we started asking, LLMs that, we fed a smart contract, and then it's like asked for, it's like vulnerabilities in it. It did find some, it didn't find some, and some of it was completely wrong about, somewhere like false positive, somewhere false negative. So we had a mixed feeling about that. Second experimentation, what we did was, we realized that, okay, the AI doesn't have a context of the code. So what if, it's a common practice in, it's like in the Web3 world that there is a documentation for the contract. So what we did was we fed the documentation to the contract, and then, it's like, then we passed on the code as well. And that resulted into a lot of hallucinations and incorrect results, because we came to a conclusion that people, although in the Web3 world, people do write docs, but they don't update it. So there will be again false positives. Then it occurred to us that when it's like there was a debate on that, it's like ChatGPT would take over, it's like programming jobs, etc., etc. And then we realized that this is not true. Someone who is going to take your job is the one who knows how to use AI as an assistant, because they will be more faster than you and they will be more accurate than you, etc. There's no one, it's like, because even to use AI you need to know how to use it. And that gave us an idea, it's like how to use AI in the product. The idea was to use it in a guided way. That was the solution to have AI at its best. So what we started doing was, it's like for all the detectors, we used to write, it's like algorithms to, it's like detect vulnerabilities. So we it's like went through our detectors again, and then we started noting down where, it's like where at what particular logic is the detectors have higher false positives, or what information the detector will need, which will enhance its capability. So instead of going the entire AI route, we created a it's like AI assisted detectors. So now what it does is like it follows its logical path, and when it has a contextual it's like need, it talks to the LLM, provides the LLM the exact functions which will help LLM to decide, what answer to give back. Once we get an answer, and then we move towards the algorithm again, and then we come to a conclusion, then write a result for that.
Can you give us some more, like some examples of that? For example, we were talking about access controls off the top. What was the type of context, or how did the LLM figure out access control good, access control bad in these scenarios?
Yeah. So, for example, it's like one common situation was, for example, that was a live situation which we were working on. So there was a contract called Shadow5 which was hacked for, it's like $300,000, and we were very happy because our tool was detecting that. But we were also unhappy because it was detecting 24 such issues, and out of that, only 2 were correct. So the problem was that it's like we were detecting incorrect but with higher false positives. So when we had a guided AI, so now the AI knew that there were like in almost like 15 of the functions, access control were in place, but it was a custom made it's like access control. So when we fed all the functions to the AI, now we had a context that, okay, it's like these are these are not common, but these are different or self-created access control logics in place, which has been used in these 15 functions which you have flagged earlier, that, okay, it's like these are access control vulnerabilities, which is not. So now the AI could it's like distinguish that it's like, okay, there was this modifier made, and this modifier which is not there in your list of common it's like modifiers. So it's like these are false positives, and then it's like rest had something else. And or maybe, for example, instead of using modifiers, what the function did was it had a require statement. Require statement is like an if else statement for it's like it's a validation statement for smart contracts. So it's like instead of having only owner modifier, I can have a line in my function stating require it's like message.sender equals to it's like owner. So these are it's like the edge cases which started getting covered because of the AI.
So, and what's neat about that is that you are identifying the assistive benefit of LLMs, and the idea that it's a classic problem. Just here's a scanner that produces false positives. How do we get rid of those without driving developers crazy, without driving ourselves crazy? That feels, your story feels pretty compelling that LLM helped there. Would you also then see, or have you seen LLMs producing code, like writing Solidity, that's more secure, less secure? Or have there been problems there that you've also seen that those bug bounties are making a couple $1 million off of?
I mean, that is something which we have solved. So it's like this was a common it's like problem statement which came to us from our customers, was that you gave us a remediation for the vulnerabilities which you found, which was found with the tool, but I really don't understand it. And it was a bigger challenge how to like dynamically produce like suggested fix. But then when we started working with the AI, what we found was, okay, we have the code snippet and we have already run through the AI for a vulnerability detection. Okay. And we have the context of the vulnerability. We know what the vulnerability is. So how about using LLM to generate an, it's like an updated code for that? And luckily, touchwood, it has worked very well for us. We launched it as a beta 6 months back and haven't heard a single complaint about it. So that's good for us. Like, so for example, if you are missing out on access control, it will tell you that it's like there are ways to fix it. It will automatically check that, oh, did you have a modifier but you forgot to use the modifier, or if you never created a modifier at all. So based on the code context, it will give you an updated code which you can use for the fix. So it does work very well in that area because the AI has much deeper context in that.
Now, a lot of this we've been talking about solidity as the language, and my two questions here are: there's a security page, the security considerations that even Solidity has. That's about, please don't misuse the language or be really careful about these areas of the language. From your perspective, just with a focus on Solidity for a moment, how complete does that feel, or do you have your own wish list about something that you'd either throw onto this security considerations page, or that you just wish the compiler did better? You mentioned a couple earlier. I'm curious if there's more.
Yeah, I mean, it's like to be very honest, it's like Solidity is still very early, and it's like there are few things which it's like our customers who are developers say that it's like okay, this is something Solidity doesn't do that, so we have to re-engineer a hack where we use like direct bytecodes. They feed in the what do you say, the what's the term for that, I forgot. The lower level language assembly, they directly include the assembly language in the code itself to to reduce the gas cost or something like that. So I think Solidity has focused a lot on features and everything, but I would love if they feature more on optimization as well, which they are doing. To be honest, they are doing. It's like with their every release, you'll see a lot of changes which reduce the gas cost. The problem here is, what happens is that some few of the things which increase gas cost has certain workarounds to reduce the gas cost. Since in it's like any smart contract, nothing is free there. So you can write a very bad code in Web2 world, and the worst thing can happen is it's like it will work slow. The website would be slow or something like that. But in Solidity, if you write a bad code, it's like you end up consuming more gas, which is expensive. It's like you have to pay to the network. So sometimes when people are trying to make a workaround because the way Solidity works, it will be expensive for them. They, they do some workarounds, and it's like then they mess up and they introduce vulnerabilities in that. So I think optimizing, very very simple example. What a lot of developers do is the by default, check for Solidity to look for integer overflow or underflow is expensive in terms of gas cost. So a lot of developers would use the uncheck. So uncheck, what it does is like it instructs Solidity that don't look for overflow or underflow here. But then what happens is that you save gas cost, but you might introduce a overflow vulnerability. So you have to be very cautious about that, it's like while fiddling with the with the features. So this is something I would love Solidity to improve.
That'd be funny, because it makes me think of like how many in the world of React, and developers who might use dangerously unset inner HTML.
Exactly.
They have to put in $10, $100 every time they call that function. That's exactly what this world of Solidity sounds like. That would change dynamics in so many different ways. The reason I was harping on, for lack of a better term, Solidity is, it doesn't have to be Solidity, for example. Now, in the world of in 2024, the InfoSec world, AppSec world is talking about memory safety. And on this top 10 list, there's no memory safety vulnerability. There's plenty of other, $100 billion problems that have come up. You've shared a couple of those with us. But do you see a future where people might be switching to Rust or compiling Rust down into WebAssembly or other languages, or Give us a little bit of sense on how you see that in terms of either a security hat on or just that developer experience. It's easier, it's safer for developers, or at least they perceive, to use a different language.
Uh, I mean, that has been a very debatable topic, and it's like there are two armies supporting. It's like there are Solidity lovers, and then there are Rust lovers. Yeah. Right now, the bigger problem is, it's like the EVMs, like the Ethereum virtual machines, the people who are supporters of the Ethereum ecosystem. They write on Solidity, and Solidity, and it doesn't support Rust. So the area is quite divided because people on Solana or it's like Near or Polkadot, they use Rust. But it doesn't mean that they don't introduce vulnerabilities. It's like, yes, Rust is battle tested, and the Rust framework for smart contracts automatically handles a lot of memory issues and everything. But then again, it's a very debatable topic because Ethereum people still love Solidity programming language. Even there were other programming languages like Viper, which came into picture, but it's hardly very popular. So the Ethereum people are still following Solidity, and it's like the Rust people are following. It's like the Solana people are following Rust. So if you ask my opinion, I'm a very pro Solidity supporter. I'm pretty sure a lot of people won't like that, but that's how it is.
That's okay. They can send feedback to me, and we'll cover that maybe on some future topic. But I think to reinforce your point is that if we talked about access control vulnerabilities, probably there's not much difference, I'm going to guess, that's a fundamental part of the language that makes one easier or worse to use. And especially if you go back to the idea of those logic errors, really easy to introduce a logic error into any programming language unless we start to get into something where it's like formalized proofs of the language, like a formal C or something like that, where we can say mathematically, based on these really complex theorems and analysis, we know what the contract said it was supposed to do is the only thing it can do, with a little asterisk that says, at least we hope the implementation matches that, and fingers are crossed.
Correct. I mean, it's like if you see the Web2 ecosystem, how they evolved. Like, I remember when I used to do bug bounties in 2013, I would look for CSR vulnerabilities. It was everywhere. But now zero CSRs. Why? Because the framework itself added features where you can easily implement, like CSRF checks and everything. Similar goes to, like Solidity as well. Like they fixed the buffer overflow and underflow things. So I'm pretty sure, it's like as the framework grows, the compiler grows, people start writing, like modules to easily, like implement. For example, the only owner, which is a very popular one, that is also developed by OpenZeppelin, an external library. So you can just, import, enable module, and then you have lots of RBAC features in that which you can implement. You can have multiple, admin roles, you can assign roles, remove roles, etc. So I think it doesn't need, like compiler level patch. That will be an issue, but yes, of course, people will write, like libraries for that and make it easier.
And honestly, I mentioned React. That's what we love to see within any domain, is just where is the framework that's just making those default decisions more secure and better for the developers, so the developers don't have to carry that mental burden of just thinking, oh, here's an input point, like what's my 10 item checklist that the AppSec team told me to remember every time, because nobody wants to do that.
Exactly.
And so speaking of those top 10, we're covering the 2025 version of the smart contract top 10. If I made you either predict a little bit, or we can just call it a wish, what does 2026 or 2027, what does the top 10 list look like in those years for you? How would you like to see it change, or maybe even become a top 9 list?
So you're asking which one won't make to the list?
Yeah, which one do you at least hope disappears, or do you think is starting to disappear because of those frameworks, or because just something within the whole ecosystem is changing in a positive way? Or we could also say getting worse, but I like to be optimistic.
Yeah, I mean, it's like I'm pretty sure integer overflow and underflow will be out. The reason behind that is like if you even see the hacks which happened, it was because they were like older contracts deployed on like older Solidity versions, because it's like zero point 0.8 was still recent, like a couple of years back. So it still compounds to the vulnerabilities. But then I'm pretty sure it's slipping out of top 10 very soon, because the new programmers are more comfortable with zero point 0.8 and above. And after zero point 0.8, it's like it is, that is not even an issue anymore. Plus, people using less, like lower than zero point 0.8 version, they have a bigger problem, because people state that, oh, you are using an completely outdated compiler version. So now it's getting outdated. So of course that's going to slip out.
So speaking of the future, then, as we start to wrap up here and let you get back to doing a lot of this fun work and fun analysis, what's something? How can people follow along more of just the analysis you're doing, the scanning you're doing, or just be able to figure out, oh, I'm worried, is this new Shashank token a rug pull or not? How do we stay comfortable here?
Yeah, sure. It's like if you want to be updated with it's like what we are doing, everything, you can just follow our blog. It's blog.solidityscan.com, and we have a public page actually, where it's like we have two things. One, it's like if you go to solidityscan.com, you'll see it's like a quick scan page. So the quick scan gives you an overview of things. Example, it's like we give a score for the it's like the risk associated with a particular contract. So we do that for for the public good, to see, okay, what things are not good. And then we have the Web3 Hack Hub, which we regularly update, which keeps you updated with the recent hacks and recent patterns of it's like vulnerabilities or exploitation which is happening in the real world. So those are the two things, it's like to keep things updated. Rest, I speak a lot on Twitter about, like, I've been speaking on Twitter all about hacks from past 10 years. So that's where my personal thing is.
Sounds good. We'll follow you there. And then since Twitter, for example, keeps you limited to a certain amount of characters, we also like to limit one last question to our guest to answer. Describe AppSec in only 3 words. So what have you got for us today?
Okay, I was not prepared for this one. AppSec in 3 words. I mean, for me, it has always been hack, sleep, and repeat. I know it's a very common term, but I really believe in that. Yeah, I mean, it's like that's my favorite word. It's like, yeah, I've been following that for a very long time. It's like hack, sleep, repeat.
That's all. Well, you're definitely in the right place to keep hacking. Hopefully, you're getting plenty of sleep, because I think even on your Web3 Hack Hub, tracking $24 billion lost to these types of top 10 flaws that you were telling us about. Web3 is going great. That website, also really informative, is tracking almost just under $80 billion lost to these top 10 types of vulns. So it's kind of important. So we appreciate you taking the time. Thanks again, Shashank.
Thank you, Mike. Thank you so much.
Want to thank everybody for joining us. Please do remember to subscribe, share about us on the socials, check out the show notes. And speaking of things that bring you pleasure or don't, whatever the topic is, check out Anhedonia by Corrine. We'll see you next time on Application Security Weekly.